right, everybody, let's take a look at section 6.3. Time to talk about the logarithmic function. This function is the inverse of an exponential. So this is going to be important for us to be able to use this to solve exponential equations where the base cannot be written as the same. And then we can use exponentials to solve logarithmic equations as well. So you can read this and understand how to read logarithms as well. So here's a little diagram to help you understand what's going on. So in this, we've got an exponential equation right here in red. And then we have our line of symmetry and the inverse of it, which is this logarithm. And you can see how they are mirror reflections of one another, which is a visual proof that an exponential function and logarithm are actually inverses of one another. So one of the first things that we need to know is how to use this reversible formula that I've got at the top of the screen to be able to rewrite each one of these logarithms in exponential form. So first I'd like everybody to do is go ahead and try to do that on your own. And let's see if you do that properly. And I'll show you how it's done. So let's go ahead and get into it. Okay, so part A, if I'm going to write that as an exponential form, let's think about this one thing at a time. So I can see that the base 2, see how it's the letter B right there? Well, look where it is in an exponential equation. So that would be 2. Okay, let's keep looking here. So do you see the exponent of x is actually the answer to your exponential equation, or logarithm equation, I should say. So that 4 will go there. And then we have an equal sign. And then finally, look at the value of y. Do you notice it's actually the value of the logarithm? And so that is the proper way of writing that equation. And it makes sense, right? 2 to the 4th power is 16. Let's go ahead and see if the other ones can be written the same way. All right, so here we go for part B. Okay, that would be 4 to the 0 power equals 1, which is a true statement. All these things should be true when you're done with them. All right, let's see about this one. See if you guys got this right. This would be 12. I'm talking about this 12 right here, to the 1st power equals this 12, which is true, isn't it? Next one, 1/4, I'll put that in parentheses, to the -1 power equals 4. And if you think about the idea behind a negative exponent, that's true because a negative exponent is a reciprocal. All right, now let's go on. Okay, now this is, it looks to be like the opposite of that, right? So let's go back to the last slide. We were given logarithms going to exponentials. Now we're going from an exponential to a logarithm. This formula, if and only if, means it's reversible. It can go both ways. So let's try this out. Let's look at the exponential equation. All right, everybody see that 5 right there? That's b, isn't it? So if I'm going to get this written correctly, I'll write my logarithm. So b is right here. That's the base of the exponential. It's the base of the logarithm. That's important. Next part. Okay, let's see here. What else do we have? Let's look at this 2 right here, the exponent of 2. You see it's right here as an x? Well, look where it is in the logarithm equation. It's actually over here after the equal sign. And then finally, the exponential function is equal to 25. That's denoted as a y. Well, look where that is. That's the value of the logarithm. So that's the correct statement. Now, let's see if you can do that for the others. So let's see, this will be, excuse me, so this will be a logarithm. The base is 10 to the 0.1 equals the exponent of -1. You just have to get in the habit of understanding how these are written. Down here, logarithm, the base is 8, that's the base of the logarithm, of 4 equals 2/3. And by the way, we'll prove this with a calculator, but these are all true statements. Logarithm, 6 is the base of, I'll put this in parentheses so we can see, this is the value of the logarithm, equals -3. And maybe worth noting as well, if we go back to the original graph, a logarithm is the blue graph. Notice that it can never have a value that's 0 or negative. That's something to think about as we move forward. All right, let's go to the next page. Now, what we want to do is we want to evaluate a logarithm. So we want to actually figure out the value of each one of these. And really what you can do is you can set these up as equations. So let me show you a sample of this. What I want to do is I want to use my exponential formula. So I'm going to convert from here to this way. I'm going to convert these into exponentials. So I think this is going to be 4 to the x power equals 64. And we've learned that what we can do is we can use a change of base formula here. And I can leave this side as 4 to the x. But over here, 64 could be 4 to the 3rd power, right? I guess I don't need those parentheses. I don't know what I'm doing there. Just write that as 4 to the 3rd power. And what we learned is that those bases can cancel each other out. And you actually have x equals 3. Pardon me, I'm getting a phone call. All right, we're back. And what we have here next, yeah, we should be back. Hopefully we're recording. Is let's go on to part B. So we figured out the value of that logarithm right there. X is 3. All right, next, part B. So once again, let's pretend this is set equal to x, let's say. And let's set this up as an exponential equation. So this will be a base of 5 to the x power equals 0.2. Now, 0.2 is the same thing as 2/10 or 1/5. So I'm thinking that this is going to make much more sense if I make it 1/5. Okay? And then the next thing I should realize is that 5 is an exponent of 1, right? So what I'm going to do is I'm going to change this 1/5 into 5 to the -1 because that's the definition of a negative exponent. It's a reciprocal. I've got my answer. The answer to that problem would be -1. So the key to these are changing the equations into exponentials. And you can get it done like this. This would be 1/5 to the x power equals 125. Okay? So I'm thinking that if I could possibly make both of these bases into a base of 5, I can get the job done. Like this one, I'm going to do the same thing I did with the previous problem. 125 is 5 to the 3rd. Now what I have here is I've got a couple exponents that could be multiplied together because I have a power to a power. So that'll be 5 to the -x equals 5 to the 3rd. I'm going to use my Exponential property. Must solve it by dividing by -1. That problem has an answer of -3, actually. Let's go to part D. Once again, let's just picture this as equal to x. So this would be 36 to the x power equals 6. Well, if I could just change that 36 into 6 squared to the x power, I think I can get this job done. I'll multiply my exponents. Of course, that 6 has an exponent of 1, right? So this will be 2x equals 1, divide by 2. There's my answer, 1/2. By using logarithm properties, I can actually solve these equations. Now we go to a calculator. And we're going to try to get the answers with a calculator. So let's go ahead and bring up our calculator and figure out the logarithm of 8. Okay, so I have a calculator here. Everybody look for your logarithm button. Here's mine. You could use Desmos for this as well. And 3 decimal places, which is the thousandth. So mine would be 0.903. Let's try part B. Now that is actually what's called the natural logarithm, or the logarithm naturalis from the Latin. We'll be talking more about that. But that button you should be able to find on your calculator as well. Here's mine. That's the natural logarithm, which, by the way, it is the inverse of E, Euler's number. So it's pretty significant. Mine's negative 1.204 if you're rounding correctly. So that's exercises on using your calculators correctly. Now, what if I want to simplify a logarithm expression or function? Well, if we could keep using that formula, I think we could get the job done. So what I'm going to do is, I've got an exponential function. What I'm going to do is I'm going to try to work it backwards and turn it into a logarithm. So let's see what that would look like. So this would be a logarithm by taking log base of 10 of y equals the exponent logarithm of 4. Now I want to point something out. This is what's called a common logarithm over here. It is a base of 10. So we can use our logarithm property of equality. If you have the same logarithms, then you may cross them out. Now you've got your answer. Okay, so it's very similar to our exponential property of equality. Let's try another one. All right, let's see if we can write this as an exponential. So this would be 5 to the y equals 25 to the x. And this looks like something very similar that we've been doing. I'm going to keep this as 5 to the y, but I'm going to make 25 into 5 squared. Let's redo that. To the x. And then I'm going to multiply my exponents together. So I've got 5 to the y equals 5 to the 2x. Y is 2x. So there's the answer to that. Okay, so let's try some of these now. Just keep these in mind. These are logarithms. So what I'm thinking we could do is transform them into exponentials, or vice versa. Okay? So the first problem it's hard to read this, but let's just say we set that equal to y. So if that's an exponential, then what we would do is we would change it into a logarithm. Okay? Now don't get confused with this, but that's actually an exponential equation. So logarithm of base 8 of y is the exponent, which is actually logarithm base 8 of x. Hard to tell the way that's typed, but that 8 is a base of that logarithm. This is y equals x. Okay, let's go over to number 14. In this one, let's just say we set that equal to y. Let's try to change this into an exponential. So what this will be is the base of 7 to the y would equal 7 to the negative 3x. Okay? Now, we can use our property of equality for exponentials. And there's your answer. These are just expressions. How about 15? Well, how about we just set that equal to y to give us something to work with. Let's change this to an exponential. 2 to the y is equal to 64 to the x. Let's change everything into bases of 2. Let's see, 2 to what power would be 64? 2 to the 6th power, I believe, to the x. So this would be 2 to the y and multiply my exponents. Cancel out your bases. Okay, here we go. Y is 6x. And then finally, about number 16, let's just say that's equal to y. Okay, this is an exponential function, isn't it? So if it's an exponential function, we should be able to write it as a logarithm. Let's try it out. So let's say this will be logarithm base e of y equals natural logarithm of 20. Now, by definition, a logarithm of base e is a natural logarithm. Or I could have changed the right side of the equation from a natural logarithm into a logarithm base e. It won't matter. It's the same logarithm, so the answer is 20. And that's the lesson for today.